Hi students, welcome to my YouTube channel. So in this video, we are going to discuss about stepper motor interfacing with 8051 microcontroller. So the 8051 microcontroller is the one of the most popular general purpose microcontroller. We all know that it is 8-bit and also available in 40 pin 12 in package IC. So let us start with our topic, that interfacing stepper motor with 8051 microcontroller. So the stepper motor is brushless DC motor and it can be rotate in a small angles, and these angles are called steps. Generally it use 200 steps to complete 360-degree rotation. That means it rotate 1.8 degree per step. So if you want to rotate the stepper motor required speed by dividing this 360-degree divided by 200, you will get 1.8 degree step. So it can rotate the stepper motor to any particular angle by giving it proper instruction. And the application that is used in many devices which needs where we need precise rotation, like robots, antennas and drives. So these are the some of the applications of this stepper motor. And next one is the normally the types of stepper motor. The stepper motors are basically two types, unipolar and bipolar. The unipolar stepper motor is very common and popular because of its use. So the stepper motor is made up of stator and rotor. The stator represents the four magnet coils which remain stationary around the rotor. If you see in this figure, A, B, C, D are the four coils, and in it, which is located around the rotor, and the rotor represents the permanent magnet which rotates. So whenever the coils energized by applying the current, the electromagnetic field is created, resulting the rotation of rotor, that is permanent magnet. So this is the basic principle of this stepper motor. Here we are using unipolar. Okay, so if you see this in figure, A coil 1 represents B, it represents coil 2, similarly C and D. So the unipolar stepper motor generally have 5 or 6 wires, in which 4 wires are one end of 4 stator coils and other end of all 4 coils is tied together, which represents fifth wire. This is called common wire or common point. If you see this figure, the A, B, C, D are 4 wires and remaining fifth one and is called common point. It can be formed, that is common wire or common point is formed by connecting one end of the two coils as shown in figure. And another one is, second one is bipolar stepper motor. There is just 4 wires coming out from the 2 sets of coils, which means there is no common wire. That is the basic difference between bipolar and unipolar. So the coils should be energized in a particular sequence to make the rotor rotate. So on the basis of this sequence, we can divide the working method of unipolar stepper motor into 3 modes. The first one is wave drive mode, second one is full step drive mode, and third one is half step drive mode. So we can see one by one. The first one, wave drive mode. So in wave drive mode, one coil is energized at a time. All four coils are energized one after another. That means if you see this table, at step 1, the coil A is energized. That means by giving logic 1 to the coil A. Similarly, in step 2, you are going to give logic 1 to coil B. Similarly, we have to follow the sequential. Once the coil D get energized, then we have to repeat the same sequence. So it wave drive mode would produce less torque when compared to full step mode, but the power consumption is very less in wave drive mode. The next one is full step drive mode. So in this full step drive mode, two coils are energized at a time. If you see this table, at step 1, the coils A and B both are energized. Then next step 2, the next two coils, that is B and C, are energized. Similarly, step 3 and step 4. The main disadvantage is the power consumption is higher. That is the difference between half and, that is wave and full step drive mode. And third one is half step drive mode. If you see the table, we can clearly understand this half drive mode is combination of wave drive and full step drive mode. That means in this mode, one and two coils are energized alternatively. That means first one coil is energized, then in next step 2, the two coils are energized, then again one coils are energized, then again 2, and so on. So we have to repeat the same. So this combination of full and half drive mode it is used to increase the angular rotation of the motor. So depends upon the application where we are using the stepper motor, we need to select which mode of operation is required. So based on the application, we need to select. Next, stepper motor interfacing with 8051 microcontroller. So while we discussing the architecture, we have seen in 8051 have totally 4 ports, P0, P1, P2, P3. Here we are going to use port 1 of 8051. That is, interfacing with 8051 is very easy. We just need to give the 0 and 1 to the 4 wires of stepper motor according to the mode. So we want to run the stepper motor. Here the stepper motor is interfaced with 8051 through this driver circuit. Here we are using ULN2003A, which is the driver circuit we are using here to interface stepper motor with the 8051. And the rest two wires, so we have discussed in the previous slide. The 4 coils are connected to stator. Totally 4 coils are there. So the 2 coils should be connected to proper 12 volt supply. Okay, so depends upon the stepper motor. Okay, which we are using either unipolar or bipolar. Here we are using unipolar stepper motor. So we have connected 4 ends of the coils to the first port pins of port 1 of 8051 through the ULN2003A. That is port 1 to port 1 totally having 8 pins. So port 1 to port, that is P.10 to P.17, that is the total 8 pins. So here you may ask, what is the need for driver circuit, that is ULN2003A. So whatever the current drawn by this 4 pins is not sufficient to excite the coils of stepper motor. So we want to boost this or to amplify the current. That's why we are using this ULN2003A. So, and also it is normally referred as driver device. It is used to drive the coils of stepper motor. So that is the main purpose we are using this ULN2003. So this is the program. So here write ALP, that is assembly language program, to rotate stepper motor in clockwise direction continuously and use 4-step sequence. That is the question. This is the very simple program here I have written. So we can easily understand this program. And one more, here we are going to use full step drive mode. So the table is clearly shown that the full step driver mode. So here we have to start with we need to load R0 register with 30H. That means it point to our required sequence. So which sequence we are using, that is loaded to R0. So here we are using full step drive mode. That means at a time or at a step 1 we need to energize 2 coils at a time. So at step 1 we are energizing coil A and B. So we need to follow the same remaining steps. So see the program here, the label look again. First we need to load 30H to hexa to R0. Then load 04 to R2. Here the 04 is number of sequence. Here totally 4 sequence. So that is why here loading 04 to R2. Then next load accumulator with the first sequence, that is R0. At R0 we are going to load accumulator first sequence, and next one move P1 comma A, that means send this value to port 1. So wait for some time. Here first sequence, here the coils A1 and B1 both are energized. So we need to wait for some time. Then increment R0. Then again increment means then it goes to next sequence by incrementing R0. Then it goes to step 2. Here the coils B and C are energized. Again you have to check how many sequences are transferred. That means decrement R2. So from 0 first, while executing first, starting it will hold the value 04. So after executing the sequence 1, it will reduce, that is decrement R2, that is it comes to 03. Again it goes to back. Again it will load the next sequence 1, that is B1 and C1. Second step, again it will transfer the accumulator data to port 1, wait for some time. Similarly we need to execute all the sequence. So once if R2 equal to 0, that means all the sequence are transferred.